So hopefully we have enough real estate to make sure that all of this fits in. We'll give ourselves a reference frame. Let's put the reference frame up at the top of the page so that we give ourselves lots of space, because I've got this free body diagram with forces going in 3 different directions now. We're leveling up. And we'll make it be, I don't know, up, down, left, right, sure. Up, down. Oh, you know what? No, let's do up, down, left, right. Sure, what the heck. Okay, let's make up be positive and to the right be positive, down and left be negative, because I can kind of see that it's going to go towards the right. It looks like force 1 is dominating over force 3, so maybe I'll make up be positive. I'm just like brainstorming out how to structure this. One way to approach this is to write out the F net equals ma first. But once you've done a few of these, you kind of recognize that, oh my gosh, I really should find the F net first, because that's something I'm going to have to do anyway. So maybe let's like refocus this. Let's say, hey, I'd like to find F net, but not only that, I recognize that there's going to be an F net x, which in this case is just F2, and there's going to be an F net y. Can you guys see that? Where it's going to be force 1 and force 3 doing a vertical tug of war with each other. And then those 2 F nets are going to have to come together to give me that hypotenuse. And so I think I want to break this down. I just want to tackle it as F net x and F net y, phenext and pheneti if you like. And pheneti, F net y, is going to be force 1 plus force 3. Force 1 is 10.0 newtons because it's up. Force 3 is negative 4.0 newtons because it's down. So we say, okay, well, pheneti is 6.0 newtons. Phenext, well, it really is just F2. So can I just write 12 newtons? You guys see that? F net x is just made up of F2. So it's going to just be the 12 newtons. Then I have this diagram on my hands. And I say, okay, well then that means that I should be able to get F net equals F net x squared plus F net y squared, phenext squared plus pheneti squared, all square rooted should give me phenet. So 12.0 newtons squared plus 6.0 newtons squared, all rooted. And I did this calculation beforehand. It'll be, I think it's 13 and change, but can you guys give me some confirmation? What is it? 13 point what? 0.4. Can you give me a few more decimal places to work with? 4164, okay. All right, because we're going to round it off, so it's nice to have some dangling digits. And the reason you want to have the dangling digits, you want to have like 2 or 3 more digits than you know you're going to round to in the end. That's a good rule of thumb, so that we don't round away things that are important. It looks to me like we're going to be rounding to 2 significant digits, so we actually have 4 more than we need in the end, and that's great. If I want to get this theta value, though, that theta value, I think I would recognize that pheneti is my opposite and phenext is my adjacent. So I'm going to use tan theta equals pheneti over phenext, opposite over adjacent. Theta equals tan inverse. Pheneti was 6.0 newtons. Phenext was 12.0 newtons. Theta therefore equals, I get somewhere around 26 point something or other. What do you guys get? 26.5651, okay. 26.5651, says Leo. Degrees, all right. Way more than I'm gonna need. But what were we trying to find again? Easy to forget. We were trying to find the acceleration. We got the F net, we've got the mass. We're trying to find acceleration. I think that draws us all the way back to Newton's second law. Newton's second law says that F net equals mass times acceleration. We're trying to find the acceleration. So we get acceleration all by itself. Acceleration equals F net over mass. We sub in our values. Well, we calculated piecewise that F net unrounded was 13.4164 newtons. The mass was given to us in the problem as 5.0 kilograms. Remember, newtons divided by kilograms gives us meters per second squared, because buried inside of a newton is a kilogram meter per second squared. The kilograms cancel out. And we end up getting, ooh, it looks like it's going to be, I don't know, somewhere in the neighborhood of 2.6. What is it?
2.68. 328.
328?
Yeah.
Nice. Meters per second squared. Now that's unrounded, but we also haven't dealt with the direction yet. So let's say that acceleration is equal approximately to 2 sig figs, I said, right? 2.7 meters per second squared. And I got to think about how I'm going to write this reference frame. It looks like it's east, rounded to 2 sig figs, 27 degrees. So I could write this as approximately 27 degrees north. Okay? Myself a little bit of a page break there. Question number 5. I look at question number 5 and I think, what am I going to do with this thing? There's an angled force. Can you guys tell me, what do you think I should do with this thing? What did you say? Yeah, look at this. The suggestion is break F2 into X and Y components. Look at this. Doesn't F2 have an X component and a Y component? And if you're told that F2, 12 newtons, goes off at 30 degrees relative to whatever left-right is. Oh, did I call this? I said east 27 degrees north, and my reference frame was up, down, left, right. That's not a good way to write this. I'm sorry. Nobody even said anything. That's the wrong direction notation for that reference frame. We should have said 27 degrees above horizontal. Yeah, why above horizontal? Because if the horizontal is this way, we've dialed ourselves 27 degrees above that horizontal. Okay? So my bad, I forgot what reference frame I used. And I should have my directional notation match my reference frame. Always, 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 always. So that was just me being a little bit too quick, I guess. Not thoughtful. All right, so let's, seeing as I messed it up once, let's do the same reference frame again. Let's use that same reference frame. We'll say left, right, up, down. Keep the right and the down, right and the up positive again. Let's deal with this thing. We gotta, as was suggested, break this down into X and Y components, which means that I'm gonna have an F2X and an F2Y. And it's hard to see my writing in there because the diagram is so small. But essentially, we want to take that F2 and we'd like to break it down into an X component, F2X, and a Y component, F2Y. And we know the theta is 30 degrees. Once we're able to do that, the reason this is useful to us to break it down is because we could think about our first free body diagram as having an F1 going this way, an F2Y going this way, and an F2X going this way. Oops, X. You see that once I break down this angled vector into X and Y components, I can sort of redraw my vector diagram to look like this. And once I have my vector diagram looking like this, we've basically just turned it back into the previous question again. Okay, it really is like a deconstructing so that we can put it back together kind of way of thinking. Okay, so we've deconstructed that hypotenuse, that F2, into X and Y components so that we can bring it back together to find a finete and a finexed. So this is the plan, but let's see if we can do it. And actually, you know what? I think I'm not going to narrate this part. I'm going to let you guys try it. I'm going to write it out as I go. And if you can challenge yourself to not look at the screen, see if you can do it, okay? If you know you can't do it without looking at the screen, yeah, you can quote unquote kind of cheat and look, okay? But see if you can do it without looking.
Yeah, it's 2.2.
And I'm going to label these out as step A, step B, step C.
Oh, yeah. Mr. Kill.
Yep. Of course, yeah.
I'm not getting a cookie this time because I'm broke. I need to go vape. I'm vaporizing.
Hey, I said I wouldn't talk, but can I point out that because F2 goes down and to the right, and I call down negative, I have to force a negative sign in here because the y component is negative. I'm forcing it in red so that you can see that I forced it in, okay? Because that F2y is a negative value.
They just used the board, right?
This side's 6, and then 10 minus 6 is 4.
I got the right acceleration. Right acceleration.
Yeah, me too. Well, why'd you use 6?
Because that's... If you draw the diagram here, and y. F2y was 6, right? F2y was 6.
F2y is... Well, F2y is 6. Yeah, F2y is 6.
So then that's
And
your
F1
opposite.
is 10.
Yeah. F1x is 10. So opposite of right. Where'd you see that?
I'm tracking my yellow FNet X and FNet Y through this problem so that we can see where they show up over and over again.
6. So 10 plus negative 6 is 4. So there's no y. We're trying to solve. We do 6 minus 10 is 15.
That's 21.0517 degrees. And step C,
You 6 because you did 10.
and I can't believe I painted myself into a corner on this one. So I'm going to cheat because I can. .2 meters per second squared And it looks like it's 21 degrees above horizontal. Okay, I'm gonna leave it there. I know that people that are doing it at their own pace, at their own time, we've got those solutions up there. You're welcome to take a look at them, but see if you can trace it out. Make sure that you can do it on your own.